Hi beta, I'm Gautam, I'm physics faculty. Now I'm going to discuss a problem based on method of mixtures. Here what I selected means I selected m grams of ice at 0 degrees centigrade and m grams of steam at 100 degrees centigrade. So m grams of steam at 100 degrees centigrade, steam temperature 100 and m grams of ice, which is ice at initially at what temperature? 0 degrees centigrade. Now what happened means I mixed these two things. I just mixed these two things. When I mixed these two things, no doubt we can treat this ice as a cold body and the steam is hot body. No doubt in that one. So ice is cold compared to the steam. So ice is a cold body and steam is hot body. So we know that whenever a cold and hot body are mixed, they will attain equilibrium temperature. They will try to get equilibrium temperature. So they will attain thermal equilibrium. Thermal equilibrium. That means they will get the same temperature. They will get the same temperature. In this process, the cold body gains heat energy. The cold body gains heat energy. And hot body loses heat energy. Hot body loses heat energy and cold body gains the heat energy, so that the two bodies will acquire thermal equilibrium. Thermal equilibrium means both the bodies will get same temperature. So whenever ice and steam they are mixed, so ice is a cold body and steam is a hot body. So this hot body loses heat energy and cold body gains heat energy and both acquire same temperature. So we have to see what temperature they will acquire and different situations now we are going to observe regarding this m grams of ice at 0 and m grams of steam at 100 when they are mixed. Let us check it out. Now first let me take I am taking first only steam and I'll go ahead with the discussion. So if I take only steam here, steam initially is at what temperature means 100 degrees centigrade, and the steam at 100 degrees centigrade if loses heat energy, no doubt we told this is hot body and loses heat energy we told. So when it loses heat energy, the minimum temperature of steam itself is 100. So now steam at 100, it has to go a step like this, water at 100. So when it loses the heat energy, steam at 100 loses heat energy means it has to go for change of state, because steam minimum temperature only 100. Below 100 steam will not exist. Below 100 means steam will convert to water. So when we are changing state, steam to water during change of state, temperature will not change. During change of state, temperature will not change. So what I did here is I have taken just one. So how many grams of steam they told? Yes, m grams of steam. So they have taken m grams of steam and they did this conversion, m grams of steam from 100 to water at 100. So if I take m grams of steam, because in the question they mentioned like that, m grams of steam and m grams of ice. So first I did m grams of steam, suppose to convert into water at 100, means what is the heat required, because loses heat we told. So what is the heat? Here steam to water, change of state. Change of state means you have to use the formula ml. We know that there are two formulae for heat regarding this temperature change and change of state. That's one is ms delta theta. When should we use ms delta theta? We have to use ms delta theta only when change of temperature in same state. Same state temperature changes. We have to use ms delta theta. But when should we use ml? We have to use ml when change of state. Remember, heat energy Q equal to ml we can write when change of state at constant temperature. Here we have two things, one is LF, other one is LV. What is LV? Latent heat of vaporization. Latent heat of vaporization. When should we use LV and when should we use LF? We have to use the formula MLV. MLV. When we have to use means we have to use this formula when steam to water or water to steam. Steam at 100 to water at 100 or water at 100 to steam at 100. We have to use LV, latent heat of vaporization. So latent heat of vaporization value is 540 calorie per gram. 540 calorie per gram. So now I can write now from that information. Here the mass is m grams. Mass is m grams. And latent heat of vaporization, already we know this value. We have to remember 540 calorie per gram. So gram will be cancelled and I am left with 540 m calories. So what is the answer? 540 m. M is, I don't know the value of m. It may be 1 gram, 2 gram, 3 gram, I don't know. So my answer is 540 m. 540 m calories. 540 m calories. So steam at 100 to water at 100, it converted means it required 540 m calories. 540 m calories. Leave this one now. Now this is what steam is hot body. Steam is hot body. It is losing heat energy and this is the process what we observed. Other thing what we have, ice. If you observe ice is initially at what temperature? 0 degrees. So now ice can convert at 0 degrees. That means by taking heat, it gains heat. It's a cold body, right? It's a cold body. So it gains heat. If it gains heat, what will happen? Ice at 0 gains heat means it can't convert to water 10 or 20. It will convert first to water at 0 degrees centigrade. After converting from water at 0 degrees centigrade and we provide more heat for this one, what will happen? It can maximum water can gain till 100 degrees centigrade. 100 degrees centigrade. Sir, why you are going two steps here, sir? In previous when we discussed steam, just you made only one step, right? Steam at 100 to water at 100 and you stopped here. But when we are discussing about ice, you told ice at 0 to water at 0, again water at 0 to water at 100. Why you are going two steps here? Two steps here. The problem is here steam is at one step and steam at 100 to water at 100 when it is losing that is heat energy in this process. The temperature is 100. The temperature is 100. But here the ice at 0 to water at 0 means only 0. But equilibrium temperature we have to get. We have to get equilibrium temperature. Starting only I told that the two bodies must be in thermal equilibrium. Thermal equilibrium means same temperature. To obtain the same temperature, what I am doing? I am going after water at 0, I am going for water at 100 degrees centigrade also. Water at 100 degrees centigrade. Here I am taking 1 gram of ice. How much gram? Not 1 gram. Sorry, it is m grams. So m grams of ice. Some m grams of ice. Small m grams of ice. Fine. Here ice at 0 to water at 0 means what formula I have to use? Yes, I have to use MLF. Change of state. Change of state MLF. And next water 0 to water at 100, what I have to use? Yes, MS delta theta. Because change of temperature. Change of temperature. Change of temperature we have to use what formula? MS delta theta. And MLF and change of state, MS delta theta when change of temperature in same state. Fine. Now what is the heat energy here? So it reached to the 100 degrees centigrade. Finally it reached to the 100 to get equilibrium. For this how much is required? So Q is equal to MLF must be there as well as MS delta theta. Here S means what it is? Water. We know that specific M into what is LF? LF, latent heat of fusion of ice is 80. LF value, you have to remember these values. LF value is 80 calorie per gram. 80 calorie per gram. And specific heat of water is 1 calorie per gram degree centigrade. 1 calorie gram per gram degree centigrade. So m into 80 plus m into specific heat is 1 into temperature difference. Temperature difference means what is the temperature difference here? Here it is 100, here it is 0. 100 minus 0, so simply I can write here 100. So finally I can write Q is equal to 80 m plus, this is 80 m and this is 100 m. So I can write it as 180 m. So this is the heat. What happened? Heat gained by ice to get 100 degrees centigrade equilibrium temperature. 180 m is nothing but heat can gained by ice to reach 100 degrees centigrade, to reach 100 degrees centigrade. Heat gained by ice to reach 100 degrees centigrade water. Fine. Now, but if you observe carefully here, if you observe carefully one point, the steam is providing how much? 540 m. Ice is how much ice want? Only 180 m. Ice want only 180 m of heat energy. 180 m of heat energy. It can take 180 m, it can reach 100 degrees. By taking just 180 m, it can reach 100. But what they are doing, they are telling we can give 540 m, 540 m. But why we want 540? Why we want 540? If 180 m is there, we can reach to the steam condition means we don't require 540, right? So what I did here, just I highlight in one step. So what I did here, steam at 100 degrees centigrade to water at 100 degrees centigrade. What happened means I got heat energy here is 540 m I got. But ice at 0 to 2 steps, ice at 0 to water 0, water 0 to water at 100. For going this turn, reaching the resultant temperature, that is the 100 degrees centigrade temperature, here heat required is only 180 m. That means we don't want 540 m. We want just 180 m of heat. So when we want 180 m, why will take more? Suppose I want 180 rupees. I want 180 rupees amount. Why I will take more? If they are ready to give more, I am not ready to take more. I want only 180 rupees. So I will take only 180 only if they are ready to give also. That means total steam is no need to convert for rising to 100, because once this temperature and this temperature both became equal, equilibrium. Once equilibrium, no transactions. Once equilibrium, no transactions. So when water ice at 0 will now is coming to water 0 to water 100, just 180 m by steam if it takes. From one steam, if it takes 180 m, it's enough. It's enough. So that it reaches 100. As water reaches 100, it also reaches 100, same temperature, no further transaction. So I don't want 540 m. I want only 180 m. That means what we have to understand here? We have to understand that no need of total steam to be converted to water. No need of total steam to convert to water. No need of total steam to convert to water. Let us take, let x grams of steam, x grams of steam condensed. Condensed means what is this term condensed? Condensed is nothing but steam to water. Condensed is nothing but steam to water. So no need of total mass m grams to be condensed. Only x grams of steam condensed, it will be sufficient readily. What is that x, sir? We will find out that one. Q is equal to, what is our formula actually we used to write? Q is equal to mLV. Now m is here x. L is how much? 540. So Q is equal to 540 into x gram. That is x. What we can write here? 540 into x calories. 540 into x calories. Here Q is equal to 180 calories. Now only x grams of, observe carefully here, very important point what I mentioned now, that is here only x grams of steam is condensed, it will be sufficient. What is that x grams we have to find. Why sir? Because if total m grams is converted, it is becoming 540 m. But how much we require? Only 180 m it required. They reaches equilibrium temperature. They reaches equilibrium temperature with 180 m only. Then 180 m only it is reaching equilibrium temperature. Why to take 540 m? If you take 180 m, sufficient energy is enough. So the steam at 100 total mass is not required to convert. Out of the total mass, if some x grams of steam is condensed, it is enough. So from this information, now I am equating these two equations. Observe carefully what I am doing. Now I am equating these two equations in the next page. That is 540x is equal to 180 m. So x is equal to, I can write 180 by 540 m, so that I can get x equal to m by 3 grams. X equal to m by 3. So now what I understood is, if just m by 3 grams, if m by 3 grams of steam condensed, it is sufficient. If m by 3 grams of steam condensed, then steam condensed means it changed to water, then ice 0 degrees centigrade of mass how much, m grams, is converted to water at 100 degrees centigrade, So only m by 3 grams of mass of steam, m by 3 grams mass of steam is condensed. It is sufficient for m grams of ice to convert to water at 100 degrees centigrade. So let us write the resultant points. The first point I want to mention, what is resultant temperature? What is resultant temperature? Resultant temperature is, no doubt, both reach 100 degrees centigrade. Second one, steam condensed. How much mass of steam condensed? Steam condensed means how much mass of steam is converted to water, that is called as steam condensed. M by 3 grams, Here how much steam left uncondensed? So what is the total mass of steam? Total mass of steam is m, right? Total mass of steam is initially m. In that m by 3 has been converted to water. How much steam left uncondensed? M minus m by 3 means 2m by 3 grams. 2m by 3 grams of steam left uncondensed. That means the steam is not converted to water, is 2m by 3. How much steam is converted to water? M by 3. Now, total water at resultant temperature. So what is the total water resultant temperature means? Here m by 3 grams of steam condensed to water, and one more is what? M. Here what is M here? Yes, M is ice converted to water. Here two things are there. You have to observe very carefully here. M by 3 is what? Steam to water is m by 3, and here m is total ice is converted to water, total ice is converted to water, and steam is converted to water is how much? M by 3. Total mass of ice means m by 3 plus m, 4m by 3. These are the results whenever they mention in the question 0 degrees centigrade ice at 1, that is a 0 degrees ice of 1 gram. This is how many grams? Sorry, not a 1 gram, right? Here m grams. So m grams. Let me take it as m grams. M grams of 0 degree centigrade ice is mixed with what? m grams of steam which is at 100 degrees centigrade. So whenever you find the question here, m grams of ice at 0 degrees centigrade and m grams of steam at 100 degrees centigrade, they are mixed together, then simply resultant temperature is 100. Steam condensed is m by 3. Steam left condensed is m minus m by 3. So it is 2m by 3. Total water resultant temperature is m by 3 plus m and 4m by 3. For example, in the exam, they have given question like this. If 6 grams of ice at 0 degrees centigrade is mixed with 6 grams of steam at 100 degrees centigrade. So my previous formula what I have written, please be very clear, don't be hurry for all the problems. This is applicable only ice 0 and mass is m, and steam also what happens, steam mass also m and it is at 100 degrees. Mass and steam, steam mass, ice mass same, steam mass, ice mass same, ice at 0, steam at 100. Then only we have to use these results, then only we have to use these conclusions and all these things. So now what happened, 6 grams of ice at 0 degrees is mixed with 6 grams of steam at 100 degrees centigrade. So this question is given in exam. So now no need to solve, right? So the first question, resultant temperature. Resultant temperature, simply we can write resultant temperature how much? 100 degrees centigrade. And steam condensed, how much mass of steam condensed? Steam condensed mass means generally what we have? M by 3. Here what is M? M is nothing but 6. So I can write 6 by 3, 2 grams of steam condensed. Now they are asking that steam left uncondensed. Steam left uncondensed means what we told? 2m by 3. So 2 into m by 3 means 2 into 6 by 3. We will get 2 into 2, 4 grams. What is total water at resultant temperature? Total water at resultant temperature. What is total water at resultant temperature means what we have to write? Just now I told it as 4m by 3. So simply 4 into m is nothing but 6 by 3. So we will get here how much? So 4 into 2 is 8. So how many grams? 8 grams. So out of 6 grams of ice and 6 grams of steam, total is mixed. 8 grams is how much? Water. 4 grams is how much? It is steam left uncondensed. In that, steam condensed is nothing but water only, that is 2 grams. Resultant temperature is 100 degrees centigrade. Here m is nothing but 6. What we are taking? M is equal to 6. So whenever they have given same mass of ice and steam, say ice temperature 0, steam temperature 100, so blindly we can follow these results for solving the problems. No need to again derive all those things. You can now follow this formula what I mentioned, all these conclusions you can take, and just in the place of m what they mentioned you can substitute. But remember, condition, only they mentioned both the ice and steam mass same. First condition, ice and steam mass must be same. Either both are 6 grams or both are 8 grams or both are 4 grams. And ice must be at 0 and steam must be 100. Then only you apply these conditions. If they have given other masses or other temperatures, then you can't apply this formulae. I hope you are clear with this one. Very important model. Thank you.